Hello, I'm Joshua Linju, and this is Quick Math. Today, before we start with linear equations, we'll quickly go over the properties, and then we'll start. So, you might be familiar with the properties already. The identity property for multiplication is x times 1 equals x. The addition identity property is x plus 0 equals x. The property of 0 is x times 0, and anything times 0 equals 0. As for commutative property, when you have multiplication as shown, right here, when you're multiplying these, you can rearrange the order and it'll still equal the same thing for both multiplication here and addition. As for associative property, we have A times B, then B times C in brackets, and A times B and B times C in brackets. And same thing with addition. When you shift those brackets, it stays this. It has the same exact value either way. Now there's distributive property. Distributive property, right? So we can have A on the outside, right? And I'm not going to put the multiplication sign because as you go further into algebra, that multiplication sign will start to disappear because, right, when they're next to each other, it means multiplication. So there's really no need for the multiplication sign. Just those who are just beginning, it might be easier for them to understand the concept with the multiplication sign there. But as you go further, that multiplication sign is not going to stay. Right? So you have something like this. Right? Or actually, let me put it this way. Right? What we can actually do here is we can distribute the distributive property. Right? So what it actually equals is AB plus AC. Right? We're going to be multiplying A times the B and A times the C. You will multiply A by everything that's inside those brackets. Let me give you a better example. So I have X plus Y. I'll get us 3x plus 3y. That's how the distributive property works. Now there's factoring. It's the opposite of distributive property. So let's say we have an equation like this. I'm going to just start to put powers in there just so that you can get used to that stuff. So right, we have this here. And that will get us, right, in factoring, you look for all that they have in common, right? 4x squared is actually just 4x times x, right? So that means this has 4x times x, 4x times y, and 4x times z. They all have 4x in common. So you can actually do this. Yeah, like that. And this is factoring. And those are the properties I want to show you. Here. And now I'll be using Desmos graphical calculator to introduce to you linear equations. But before I get to that, you have to learn a bit more about the coordinate plane and how it relates to equations. So I'm going to start with proportional equations. Proportional equations are quite simple, right? I'm going to start with the most basic equation, right? Y equals X, right? Proportional equations always start at the origin, and the origin, let me just quickly define the origin. It's this, the center of the coordinate plane, the center of everything, right in the middle. 0 on the x-axis and 0 on the y-axis. All proportional equations cross this, right? Y equals X. Now there's also slope, right? Every proportional equation goes at a constant rate or a constant slope, right? And in this case, the slope is 1. There are multiple ways to determine the slope. Graphically, right? There are 2 ways to do it graphically and 1 way to just do it by looking at the equation, right? So by now you should know that X is 1X, even though that's not going to be acceptable higher on. They're not going to really want you to be writing as 1X. But what X is actually 1X, right? So the coefficient of X is 1. And in linear and proportional equations, right, that coefficient is the slope. So here we have a slope of 1. Now, what does that mean? The slope is basically how steep, for every time the x moves 1, how much does the y move? So here we have the origin, right? As we move out to the x, and the x is 1, right? The y moves up 1, right? And it's going to keep going. When this moves out 1, that moves out another 1. When this moves out another 1, that moves out another 1. And it keeps going on and 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 on to infinity. To infinity. All the way to infinity. Doesn't stop. There we go. Yeah, and it keeps going at that same constant rate. Now let me show you another proportional equation. X. See the difference? Y equals x is green and y equals 2x is, y equals x is red and y equals 2x is green. Right? Same exact concept. When the x moves 1, the y is going up 2. Every time the x moves 1, the y moves up another 2. Right? That's the constant rate. As you see, the coefficient here is 2. And that is the slope. Right? I can put another equation. Right? I can put 3x. Right? I can put another. Right? And the slope, the steepness, is going to continue to increase. As you see these different lines, the steepness is increasing as the coefficient increases. So that's the slope. Now that's just only one way to view the slope. There's another way, right? Now let's say I'm going to, hold on. Okay. Now I'm going to make wait, hold on. Before I start with that, what I'm going to do is actually first just get to y-intercepts and x-intercepts. Sorry about that. Alright, so now I'm going to add 2x plus 2, right? Look at the difference. I'm going to put 2x beside it, right? The equation 2x. I'm going to put that right next to it. So, hold on. Look, see the difference? The whole thing is 2 higher than the previous graph. And that is what this 2 does, right? Now, instead of intersecting at the origin, the graph will intersect at O2, right? That means the y-intercept is 2. Why is it called the y-intercept? Because it intersects the y-axis at that point, 2. Right? And that's how intercepts work. You can have 3, 4, 5. It's just going to continue to move up. Right? And that's how intercepts work. Right? This works for any right? You can have this. X plus 2 with x. Look at that. That's how intercepts work. Now, there's something else you might be wondering about these linear equations, right, that I'm now showing you. Right? Intercepts means where it intersects a certain axis, right? So what about the x-intercept? Now, we will be using some algebraic operations to solve for this one. If you aren't familiar with this sort of stuff yet, go back to my previous video and watch Intro to Algebra or Pre-Algebra. Okay, so we have the equation y equals 2x plus 2. Right? Now how do we find the x-intercept? And what we do here is we actually isolate x. Once again, if you don't know how to do that, you should go back to my last video on Introduction to Algebra, or Pre-Algebra, is what we call it. This is still sort of Pre-Algebra too, but yeah, it's sort of in between. So what I'm going to do here is isolate the variable. First thing we should do in this type of equation is sort of get that constant away from the x. So what we can do to eliminate that constant is minus 2. Right, we get minus 2 to both sides. That gets us y minus 2 equals 2x. And then, right, we divide the whole thing by 2, and that gets us y minus 2. Let me just divide the whole thing by 2, and that's our x. And what we can do here is actually fraction and have half y and minus 1, right? And we have x here. And this is what x would equal, right? We know that, but you may still be wondering, but what is the x-intercept? That's what we started out looking for in the first place. The x-intercept is right here, -1, the constant. And look here, the x-intercept is -1. The x's spot right there. Right? That's how the x-intercept is found. Right? The y-intercept is straightforward. The x-intercept, not quite. Now, what will happen if we had a graph, right, of a linear equation that we didn't have the linear equation itself? How will we find the slope with just the graph? You can pause this video to think about it. Okay, so what we can do here is we already know the equation, but assuming we didn't, right? So even though we already know the equation, we'll try to find the slope without just using the coefficient, right? How to do that is we can use this formula. Y y2 minus y1, right? And we put this all in a fraction, so I have that here. X, the underscore, this. And it might look confusing, so I'll explain. So I'm just going to put up a table, right? With the X and the Y, right? And let's start plotting points. So first I'm going to plot the points. Let's see. How about coordinate here, this point? So just plot it. Right there. Right? 06. And let's plot a second point. Let's do 1, 8. So like that. And we have these 2 points. And let's put this into the table. So we have 0 and 6 and 1. Right? And this is our y1, right? Our x1, right? The first x coordinate and our first y coordinate, y1. Here's our second y coordinate, y2, and here's our other y coordinate, x2 and y2, right? So what we're going to do is substitute in these values. So we're going to take it, right, and write it out as a fraction. So we have 8 minus 6 and 1 minus 0. And that gets us 2 over 1 equals 2, right? 2 is our slope. We've just found it out by using just the plots, the points, right? So let's say this equation wasn't here. This thing wasn't here, right? This is how you would find the slope without the equation. Now, moving on. Next, let's say you have 2 equations like this. Here we have right? And let's call this row our row 1. Call this our row 1, right? Row 1. Let's call this our row 2. So we have our row 2, right? And what we're going to do is solve for the x coordinate and the y coordinate. These are both linear equations. This is a concept of simultaneous linear equations. It might sound complicated, but it's not really once you get the hang of it. So let's begin, right? The first thing we have to do to solve for any variable is try to isolate the variable. In this case, there's a different way of doing so. One way we can do it is, you try out different things when you're trying to solve these type of linear equations. So first you eliminate one, so it could be either the x or the y. Then the next thing you will do is solve for the other value, then come back, substitute the value in to solve for the other one. I'll explain throughout the process. Right, so we have R3. These are abbreviations for, R2, abbreviation for row 1 plus row 2. And that will get us 5x plus y equals 11, because we're adding 3 and 8 too, right? But nothing's isolated yet. So what we can do is continue like this, right? We'll call this row 3. And we take this row 3, and we can add it with row 1 to cancel out y. So let's do that. Let's just do exactly that. So we have row 3 and row 4, and we add them, and we get 7x all on its own. And we add 11 and 3 to get 14. 7x equals 14. And this will be our row 4, even though that's not necessarily going to be necessary in this case. But it's just best to arrange everything neatly so that you can always track back your work. So right, we've finally gotten to the point where the variable is isolated. So we now have 7x equals 14. And what we can do is basically divide both sides by 7. So let's start with that. 14. And we take both sides, right? And we divide both sides by 7. X equals 2. And what we've just done is we've just solved for x like that. With two variables inside the equation, we have managed to solve for the variable. We solved for one variable, right? And now you may be wondering, what about the other one? I'll get to that. Now, right? Our solution. Next, we substitute in the value. Just like we did in the formula where we substituted in the real life values into the formula, we're going to do the same thing here. Substitution. We have x equals 2. You can choose either one of these equations, right? We can choose this, row 2, or row 1, right? So let's just go with row 1 for substituting, right? So now we have this, right? We're substituting in that value. It's going to be minus y equals 3, right? And this is row 1. And if we continue to simplify, right? 4 minus y equals 3. Continue. Subtract 4 from both sides. So we have subtract 4 from both sides here, right? Negative y equals -1. Right? And now what to do to get plain y, not negative y? We should multiply both sides by -1, because negative times negative always gets us positive. So we can multiply by -1 to get y. And that will get us y equals 1. You just solve for both x and y. Like that. Well, final solutions. And we have a coordinate. Right? Our final solution is this right here. Right? Now, you may be wondering, okay, I understand, but what does this really have to do with linear algebra? Now, let me show you. Right? What we've just found is what we've just done is found where two linear equations, right? Where two linear equations intersect. So we have two linear equations on the same graph, and we've just found where they intersect by doing the simultaneous linear equation. Now, let me explain further. Right? We started with our two equations up top, right? Hold on. Right here. Right? And this. And basically, once, I'm not going to go through the whole steps, but eventually you'll figure out when you rearrange the terms here. There's no complicated process to it, right? Once you rearrange the terms, you'll find it is equivalent to this, right? When you add y to both sides and then subtract 3, we will get, for the first equation, y equals 2x minus 3. Looks a bit more familiar now? Okay. And the same thing for this one, right? We're going to subtract 3x from both sides. That gets us, let me just do it here, right? 2y equals -3x plus 8, right? And we divide both by 2 to get us plus 4. And yeah, these are our two equations. I'll put them down here, right? And what we basically did is found where they intersect, where they cross, where the two paths cross. So we have something, here we have, right, this graph. Like we have a graph here. And our other line There we go. And they intersect at the point we calculated, right? 2, 1. Look at that. And basically, when you're solving that simultaneous linear equation, you are basically finding the place where both of these equations intersect. Right? That's all you're doing when you're doing a simultaneous linear equation. That's all for now. This is linear algebra part 1. In the next video, we'll be introducing matrices and how matrices relate to linear equations. And in the video after that, we'll be learning more about matrices and determinants and more complicated concepts from there. I'm Joshua Lyonju, and this is Quick Math.